Now this address is nothing but the address location of particular slave. So whenever master want to write the data, see this diagram, whenever master want to write the data into the slave, so again in this slave there are so many locations in the memory, so into which location it want to write, so that address in this case it will become write address, or it can be read address. How? Whenever master want to get the data from slave, from which location of the address it want to get the data, in that case it will become a read address. So this address can be write address or read address. Here read and write both won't happen at a time, they happen at different times. So same address for read and write also common. Okay. Now next signal p prot. This p prot nothing but to indicate whether the transaction is a secured access or non-secured access. It is about protection. Secured means we are providing security to the transaction, or we are providing protection from the illegal transactions. Okay, now we'll see about this p prot signal. So in the spec only it is there. I will scroll down just a minute. Okay, so this p prot or protection signal is a 3-bit signal. You can see p prot of 2 down to 0. It can be p prot of 0, p prot of 1, p prot of 2. So this is p prot of 2, this is 1, this is 0. This p prot of 0, that value can be equal to 1 or 0. And for 1 also it can be 1 or 0. For 2 also it can be 1 or 0. Suppose when p prot of 0 equal to 1, it indicates privileged access, else normal access. When p prot of 1 equal to 1, it indicates non-secure access, else secure access. When p prot of 2 equal to 1, it indicates instruction access, else data access. Now what is meant by privileged or normal access? Suppose if you see the buses or trains, there are some seats reserved for MLAs, MPs, some VIPs, special, for special people. So here out of all transactions, if there are any transactions which are special, those are called privileged. In that case we can indicate that privileged transaction by making p prot of 0 equal to 1. If there are no privileged or special transactions, we have to make that bit as 0. Okay, that is called normal access. Suppose secure or non-secure. If we want to provide protection from illegal transactions, if we want to make the transaction as secure, then we have to make p prot of 1 equal to 1. Yes, it will p prot of 1 equal to 0, it will become secure, else non-secure. Okay, we don't want security. When we don't want security, you have to make p prot of 1 equal to 1, else 0. Okay, and there are instruction and data access. When there is a write transfer, read data transfer, write data transfer, those are data accesses. Okay, some other control actions, p write equal to 10, p ready 10, p select 10, these are all called control actions to control the functionality or these transactions or the working. Okay, so when p prot of 2 equal to 0, it indicates data access is happening, else instruction access is happening. So here in this privileged normal, instruction data, secure, non-secure, nothing but this indicates secure, nothing but protection. Even though there are so many options, why we calling this as protection? Because this is mainly for this primary, these two are secondary, privileged instruction. That's why this is called pprot. Okay, now we'll go to other signals. Okay, where is pprot? Here. So pprot completed. Now p select x. We'll see this. That x indicates slave number. See here, if x is 1, that can be slave 1. If x is 2, that can be slave 2. Slave address. Now you may confuse slave address means. Suppose p select x indicating whether slave 1 or slave 2. In that sense, slave address I told. P address indicate in the particular slave particular location. Within the slave particular location, that is p address. P select x will tell the this slave or this slave or that slave. Okay, right. Now p enable. Okay, so when you want to do transaction, you have to select particular slave. It means suppose you want to communicate with one person, you have to, there are so many persons, so many slaves, so many persons, you want to talk to particular person, or you want to communicate particular slave here. So that is called selection. To select to whom you want to communicate, that is called slave selection. But after you selected some particular person, you have to know, you have to send the request to that person, I want to communicate to you. That sending request is done by p enable. When you want to do write or read, okay, so writing into the slave or reading from the slave, you have to send the request to the slave. To sending that request, we use this p enable. Okay, now this p write, I told at one time we can do only write, at one time we can do only read. So in that case, at that time, whether it is doing write access or read access will indicate by this write. Now then, write to data. This data is nothing but when you writing, whatever the data you writing, that data signal. Now p strobe, we'll see about this strobe in detail. Okay, now I told in each memory location of the slave there are 32 bits. 32 bits maximum. It always no need to be 32 bits. Suppose in any APB coding, if you see the data bus width 32, less than 32, that indicates their maximum capacity is 32 location capacity, but they are using less than 32 bits. It can be less than 32 also, maximum 32. Okay, so this location, each memory location of the slave will be divided into 4 parts. Okay, this is called byte addressing. This is first part, second part, third part, fourth part. Each part is 1 byte. Okay, so this each part contain 8 data bits. That 8 data bits you will indicate by 1 strobe bit. So strobe is 4 bit. If this is 1, this is 1, this is 1, this is 1, all 4 bytes are ones, means we are communicating all 32 bits. We selected all strobe bits. Suppose if I do 0 111, I want to communicate only 24 bits. In that case, it won't be selected, these 3 will be selected. Okay, so this strobe indicating when you want to send less than 32 bits, when you want to communicate read or write. Oh, this is applicable to only write. This is not applicable to read. In the read access, this all strobe bits will be 0. In the write only, it can be 0 or 1 based on the how many bits you are communicating. So this strobe is always a write strobe. Okay na? Right. And here you can see in the spec one formula with respect to this strobe. I will show that. See here this formula. Substitute n equal to 0. How much it will become? This will become 7. 8 into 0, 0 plus 7 means 7, and it will become 0. 0 to 7. It means when n equal to 0, you want to communicate only 8 bytes. Okay, strobe 0, strobe of 0. Okay, because strobe of 0 means 0 to 7 na? When n equal to 1, it will become n equal to 1. So n into 1, 8 to 15. In that case, you want to communicate only second strobe. Okay, so that is the indication of this strobe formula. Okay, right. Anyhow, strobe completed. Now ready. See, when master requested, when slave is ready, it will take the data. When master send the data, when slave is ready, it will take the data. Or when master ask the data, if slave is ready, it will give the data. What I told, when master want to send the data to the slave, when slave is ready, it will take the data. Slave take the data. When master want to take the data from slave, when slave ready, it will give the data to the master. Okay, this is about readiness of the slave. Okay, that signal, response signal. P enable is a requesting signal. This is a response signal. So request plus response is called handshaking. Okay, yes, I am ready, like that it is telling. I am ready to take the data, or I am ready to give the data. Okay, now PR data. Whenever you doing read transaction, that read data is nothing but this signal. Now slave error. You know, some transactions may fail. There are successful transfers, there are unsuccessful. To mention unsuccessful transactions, this slave error will be useful. This ready equal to 1 means successful transaction. When ready equal to 1, slave error should be 0. If slave error equal to 1, it indicates failed transaction. Okay, right. So what about the signal clock? It is working with the positive edges. At positive edges, transactions will happen. Reset means whenever you make the reset, you will come to idle state. So this APB will work in 3 states: idle, setup, access. When you reset, you don't want to do any transaction, so you will be in idle or reset state. Okay, address. So when you want to send the data or take the data, that address is giving by this one, pprot. I told about pprot. I told about select. When this select x equal to 1, that indicates you selected the slave. When this value is equal to 0, you have not selected. It means if I selected slave 1, p select x equal to 1, p select 1 equal to 1. It means you selected the slave 1. P select 1 equal to 0 means you have not selected the slave 1. Like that. P enable. When enable equal to 1, you requested the slave. When enable equal to 0, you have not requested, because you don't want to do any transaction. When P write equal to 1, write transaction is happening. When P write equal to 0, read transaction is happening. PW data, you know, P strobe, you know, P ready. When P ready equal to 1, yes, slave is ready, so transaction will finish, either write or read. slave error. When slave error equal to 1, it's a failed transaction, else successful transaction. Okay, right. Now we'll discuss about state diagram. If I explain timing diagram, you will confuse. So to get the clarity, better we'll go to state diagram, then we'll come back to timing diagrams. State diagram nothing but a state machine. Okay, so this APB will work in 3 states. There are 3 states in the state diagram. This is idle state. It means you don't want to do any transaction. It is nothing like a reset state, starting state. This is setup state. This is access state. Okay, so first you are here. You don't want to do any transaction. If you don't want to do any transaction, you will be here only na, no transfer. But if you want to do transaction, you will go from idle to setup state. That's why transfer. So when you don't want to do any transaction, you won't select any slave, you won't request any slave. That's the indication of these 2 zeros. But when you want to do transaction, you will select particular slave na? But still you have not requested any slave. You just selected the slave, but that slave you have not requested. So this is called setup. So when you selected slave, you will go from idle to select. When you will select, when you want to do any transfer. And you will go to setup to access state when you requested any slave. You selected and requested. So you will go to setup to access. Okay. So when you requested the slave, if that slave is ready, transaction will complete. If that is not ready, you will be in the access state only. After completion of the transaction, if you want to do again another transaction or another transfer, again you have to select the slave. So you are going. So this is when you want to do another transaction. In this case, P ready should be 1 because slave should be ready na. Okay. But when you don't want to do any further transaction after completion of one transaction, if you don't want to do any further transaction, you will go to idle state. That is indicated. Here also P ready 1. Okay, but no transfer. That's why you are going to idle state. Okay, so we'll code this state diagram with Verilog. That time you will know more about this. Okay, now we'll go to timing diagrams. So timing diagrams will tell the actual functionality. Of course the state diagram also telling, but now we'll know more about it. And especially in interviews they will ask you to explain this APB with the timing diagrams, because if you know timing diagram, they understood you know the concept well. If you don't know the concept, you cannot understand the timing diagram, or you cannot explain with the timing diagram. Okay, so here, so I told this is a industry level project. You will understand the flow. So what is the flow? So this is the spec. This spec will read by both RTL engineer, they will do DUT coding, and it will read by DV engineer also. Both will read. However, we learning digital concept. Suppose in digital you are learning some concepts, no? This is also like that concept, but digital concepts are small, this is big, that's it. Okay, so in the digital, after learning the concept, what you are doing, you are coding with Verilog. Here also after learning the spec, you will code with Verilog, DUT coding, and you can code test bench also with Verilog or system Verilog or UVM, but the design code will be Verilog only. Okay, or VHDL. Okay, so either DV engineer or RTL engineer, first they have to read the spec. So in any project, the primary step is reading the spec, understanding the spec correctly, knowing the functionality of the project or protocol correctly. Everyone will do this only. That's why you can observe in the notifications, we want a person who know the APB protocol, who know the AXI protocol, who know the PCIe protocol. Okay, if the requirement is PCIe protocol, they need the people who know the spec, who know its functionality. Okay, now so that is the primary step. So after going to the job, you will revise the spec. Before selecting into the job, you should know about the spec and you should know the coding also well. And they will ask questions on the spec, how you know it well, how you are good in concept and coding. If you are good, you will be selected. After selecting, you have to revise the spec again. If there is a time, you will revise. During that revision, you can interact with the teammates and leader. You can get clarification of doubts and you will get more information. Okay, if there is no time, you have to immediately start the working of the project also. Okay, so after reading the spec, a RTL engineer will do RTL coding, and DV engineer take that RTL code or DUT code and he will write the test bench code. In the test bench, he will write test cases. With the test cases, he will check the RTL code is properly coded, design functionality is properly coded with respect to the spec or not, he will check. Okay, so as a RTL engineer, what is the duty? Reading the spec and coding DUT coding. DV engineer, what is the duty? Take that RTL, take test bench, write test bench, nothing but write test cases and develop test bench components and verify the functionality of this DUT coding with respect to the same spec. Detect the bugs if any and report to the RTL team. They will make the changes, again verify it until it became bug free. This is called verification. So in the companies or when you go to projects, RTL engineers will write the RTL codes. DV engineers will verify that RTL code by writing test cases and test cases in the test bench. Or these projects may be like a team. All DV engineers may not write test cases. Some may write test cases. Some may develop test bench component. Some may work on coverages. It's a teamwork, group of work. Okay, so now I hope you got the idea. So if you go to the job or if you applying to the job, what should you know? If they ask about this project, you should know about the spec and coding. If you are applying for RTL, you should know how to code in Verilog. If you are a DV engineer, you should know how to code in UVM, because industry standard verification is UVM. First you have to do with Verilog, then SV, UVM, like that. Ultimately you should reach to UVM. So when you go to project, you want to do whole project, you may write test cases or you may develop components, test bench components, some part of the work. Okay, I hope you understood how industry projects flow or how they happen. Okay, na? Right. So now we'll discuss about timing diagrams, nothing but a waveform. So there are total 6 timing diagrams we have to know. 3 are belongs to write transfers and 3 are belongs to read transfers. Again in 3 diagrams, 2 diagrams are successful transactions, 1 diagram is failure transaction, both in write and read. Again in 2 successful transactions, one is with wait states, one is without wait states. Here wait states indicate after completion of one transaction, if you want to do further transactions, then you have to wait until completion of the transactions. That is the meaning of wait. Okay, so first we'll start with the write transaction. In the write transaction, first you have to know without wait states, then you have to know with wait states. This with and without wait states are successful. After successful, you have to know failed also. Okay, so in the failed, there can be wait, there cannot be wait. Okay, alright. So This is the first diagram. If you understand this diagram, you can easily understand remaining diagrams. Okay, first I will explain this very detailed, then I will give you shortcut to know it within seconds or to explain it within seconds to anyone, even in interviews. Okay, so this is the diagram. So these are the clock edges. So in the diagram, first what you have to see, you have to look into first clock edge. That also positive edge. Where is the first clock edge? This one. Okay. In this first clock edge, there are so many signals here. What you have to look? You should look into only select. Don't look into other signals. Only select, because why select? When you want to do transaction, you should select some slave. If you are not selecting any slave, you don't want to do any transaction. If you don't want to do any transactions, you no need to worry about any other signals, na? Okay, so you look into select in this first clock edge. In this first clock edge, whether select is 1 or not, that you have to observe. When it is 0, it means slave not selected. It means you don't want to do any transaction. You will be in the idle state. So at T0, we are in idle state. We don't want to do any transaction. Okay. After this first clock edge, you have to go to second clock edge. In the second clock edge also, what you have to look? Again you have to look into P select only until P select becoming 1. You have to look into select only. Suppose here also P select here going to high. It is not going to high. Then again in the third select also you have to look into third edge also you have to look into select only. So you have to look into select until it is becoming high. That's it. So in the second edge, it is about to going high. It is exactly not high here, but it is about to going high. Yes, that point you have to observe. So when it is about to going high, that edge is indicating the starting of the setup state. So from idle to you came to setup state. It means you selected some slave here. You want to do transaction. Okay, whenever the select became high, at the same time right will become high. See, it became high. Why right became high? Because you want to do right transaction. This is belongs to right, na? Right transfer, na? So in the right transfer you have to do whether it is 1 or not, right? Or you have to make right 1. Okay, if it is a retransaction, this right should be 0. Okay, so you selected and right is 1. At the same time you can see the bus change in the address and you can see the bus change in the data also. Here at this point you no need to worry about ready and you no need to worry about enable. However they are starting, they will be at that only. Okay, so whenever you observed select is going to high, at the same time this should high. There is a bus change here, there is a bus change here. You don't bother about P enable and P ready here. Okay, so this APB will be in the setup state. This is setup state only for one clock edge. In the next clock edge it will go to access state. Remember this. So you can blindly understand from here to here. When you go to here, this is the next clock edge, you entered into access state. This is the idle state, this is the setup state, this is the access state starting. This is setup state starting, this is access state starting. Okay, so whenever there is access state started, in the immediate clock cycle access state will end. It means it will end at T3. When it will end? When there are no further transfers. So access started here, transfer started here, transfer ended here. When there is only one transfer, it will end. If there are further transfers, it will continue. So here it is ending, it means there are no further transfers. So this is the setup state start, this is access state start, this is access state end. Whenever access state end, immediately after that edge you can observe select becomes 0, enable becomes 0. Okay, but this address continue, and you can see the bus change in the data, and this write also continue, same continue. So these two change and this bus change, and this also will change. See here how we are telling transfer is completed. See here this ready where it became high. So until from starting to here it is not considerable, because I told ready is a scalar but it is looking like a bus. It means at the same time high, at the same time low. When both same time high, same time low, this is from here to here it is not considerable. From here to here only it is considerable. This also not considerable. So this here to here it is not one here, it means it is not ready, but here it is ready. So transaction completed. When transaction completed, data also completed. See, data started here. When we selected, data started. When ready is 1, data taken by slave. This is right data transfer completed. Okay, and one more thing observe, whenever select became 1, from that time whatever the select until access complete it will maintain same from here to here. Write also will maintain same, address also will maintain same, data also will maintain same. That also you have to observe. Okay, right. So here to do this transfer, how many clock cycles it needed? APB need minimum 2 clock cycles, not exactly 2, minimum 2, to do any transfer or any transaction. Okay, so how you count the clock pulses? Whenever setup started, that is the starting. From here to here 1, from here to here 1. So when setup started until completion of access, we have to count the clock pulses. So to do here one transfer, it taken 2 clock cycles minimum. Okay, right. So here I explained very detailed. Now count the time. Within few seconds you will understand it. Okay. So now I shown this diagram, or somebody shown you in the interview. Immediately what you have to look, first clock gauge and select 1 or not. So it is idle because it is not 1. Next clock gauge until it become 1, you have to, okay, you have to look into, okay, it is becoming high, so this is setup started. In the immediate next clock gauge, access start. In the immediate next clock gauge, access end if there are no transfers. Okay, at this clock gauge you look into this whether ready equal to 1 or not, and at this clock gauge you look into error also. If the error also 1 here, it's a failed transaction, but ready 1 error 0 means it's a successful transaction. That's it, easy. And you look into whether it's a write data or read data, or whether p write equal to 1 or 0. It is 1, so it is write transaction. You can easily understand. Okay, see here this is blank, this is dark, this is again not blank but not dark. It indicates there is something, address is there. It indicates this is undefined, don't care, XX. It indicates there is no data, there is no X. Okay, that is the indication. Okay, right. Now we'll go to write transfer. Here why we are telling no wait states? Suppose this is the start of access, this is the end of access. After starting the access, if it is not ending in the immediate clock gauge, from here immediate clock edge to we count the ending clock edge. So from here to ending clock edge we consider as wait states. When wait states will come, when after one transfer completed, if there are further transfers, then you have to wait. Those are considered as wait states. Here after this transfer there are no further transfers, because how I am telling no further transfers, you made this select down, you made this enable down. When you made select down, you don't want to, you have not selected any slave and you are not requesting any slave because you don't want to do any transaction. Based on that I am telling. So here started, here ended, so there are no wait states. From here to here if there are any transfer, those are considered as wait states. That's why this is without wait states, no wait states. Okay, now we'll go to write transfer only with wait states. Okay, here also same, what you have to look into first clock is select 1 or 0. Here select 0 idle. Until it becomes select 1 you have to look into. Okay, here it is becoming 1. So this is the setup started. When setup started, it will be in the setup state only for one clock edge. It means in the next clock edge it will go to access. If it is started access, in the immediate clock edge access has to end. But access is not ended. It means if access not ended, it means there are further transfers. How many transfers? From here you have to count. This is the ending of access. From here to here 1. From here to here 1. After this you made this select down, so transfer completed here. So how many wait states? From here access ended here, from here to here 2 cycles, means 2 wait states. Okay, so how I am telling here transfer is not completed, because after this also you not made down, na? That's why. See here the same address will continue, because you want to do write transfer to the same slave. Whenever there is same slave, you will keep same address. You are sending to same address, maybe byte by byte with a strobe. Okay, right. I hope you understood. See here, whenever access completed, here ready is 0. It means access not complete, slave not taken. Here also not taken, but here see slave taken. Slave is ready. Whenever it is ready, whenever it taken, that time it will complete. Again here also at this time error should be 0. Here we are not showing error, here error should be 0. Then only successful. But even it is ready is 1, but error is 1, it is a failed transaction. Okay, now see here, to complete the all transfers, how many clock edges is taken? This is the setup start. From here to here 1, from here to here 2, from here to here 3, from here to here 4. So here it taken 4 clock cycles to complete how many transfers? 3 transfers. From here to here 1, 2, 3. So for 3 transfers it taken 4 clock cycles. Here for one transfer it taken 2 clock cycles. Okay, here there are no wait states, here 2 wait states. Both are successful transactions, both are write transfers. See here write data and p write equal to 1. Okay, na? Now we'll see failed to write a transaction. Failed to write a transaction, it is there below, not in immediate. Okay, so this is the failed to write transaction. How I am telling failed? Same second diagram with wait state only. What I told, whenever saves became select became down, at that time you observe the p error position, slave error position. So at this time it is 1, even though ready is 1. even though ready is 1, when it is 1, what I told, transaction completed. This ready one telling transaction completed, this one is telling transaction failed. Transaction completed but it is failed, not received properly, right, not happened properly. Okay, here also two wait states but it is a failed transaction. Okay, right, previously diagram two wait states but it's a successful transaction, right, happened properly. Now we'll see read transfers. In the read also, first without wait states, then with wait states, then with error, failed transaction. Okay, see here what we have to observe in the read transaction, read data will be there, and here also first we have to look edge, then p select is 1 or not. It means p select is not 1. If you see like this, it is not considerable, but here it is becoming 1. So this is what state? Setup state started. Here we cannot say this is not 0, no, this is ideal state, we cannot say like that, but this is setup state started. It will be in the setup state only for one clock edge. It means immediate clock edge is access start and immediate clock edge is access end when there is only one retransfer. So how I am telling this is ending, here select became down, that's why only one transfer. So at this time ready should be 1, yes, ready 1, so data completed, read data taken, slave send the data, master taken the data, read transfer completed, only one transfer. Here also no wait states. Here also for one transfer it taken 2 clock cycles minimum. Even in write or read it will take 2 clock cycles. Okay, right. So you have to observe P right here. Okay, and P or data. Now this one, here wait states will be there. See here, this is setup started, access ended, but not ended. Here it has to end because you have not down the select. That's why from here to here wait states. Here you down, here access completed. So here 2 wait states and 3 transfers, 3 read transfers successful, because here we are not showing error, we are assuming error is 0 and valid is ready is 1, so successful, data taken. Okay, now we'll go to with wait states, error, okay, read error. So in this what you have to observe, same diagram. At p select down, at this time ready 1, it means slave is ready, but error is 1, so transaction failed, read transaction failed. Okay na, right. So in this lecture you understood the functionality of each signal of APB, timing diagram and states, and state diagram and states, and timing diagrams. Okay, so some other also there, some more details, little details are there. Whatever the details I have not included, those I will include in during coding. So next lectures will be continuation, will be coding. First we'll do with Verilog design, then Verilog test bench only will do, will verify, then we'll do design in Verilog, test bench in SV, then we'll do design in Verilog, test bench in UVM. Okay, so that you can understand one industry, basic level industry project with Verilog and in all verification environments, system Verilog, UVM. Okay, and you can keep this project in resume also, but you can keep in resume. If you are a RTL engineer, you can keep, you did the RTL coding. If you are a DV engineer, you have to keep as you worked with UVM verification, not SV also you can keep, but Verilog verification not suggestible, either SV or UVM suggestible, UVM more suggestible. Okay, that also you have to mention. This is APB4. Suppose if you did coding APB3, in the resume you have to mention as APB3 or version 1. but if you include this p prot and strobe also, it will become, in the coding it will become APB4. So that name also you have to mention in the resume, not simply I worked in APB. Okay, and in resume what you have to keep, you have verified the features of the APB protocol. And I told why it is called protocol. So to do this all transactions, I told this should be 0, this should be 1, like that na. Telling these rules is nothing but protocol. So whenever there are two components, master and slave, just by connecting, communication won't happen properly. You have to follow some guidelines rule. This should be 0, this should be 1. By following these rules in the communication, it is called protocol. Okay, so in the further lectures while explaining coding, if I forget any, I have not included any important points, I will include there. So with coding you will know more about. Even in coding, after executing, same timing diagrams we will analyze. Okay, that time you will know more about it. Okay, so spec or theory concept almost completed, 90%. Okay, right.